Okay, topic 19.3, we're going to be looking at function applications with cylinders. So let's look at the first example. It says, if the volume of a right cylinder is 400 pi cubic units, write an expression for its lateral surface area as a function of its radius. So remember what we're doing here. We want to write an expression for the lateral surface area of a cylinder as a function of its radius. So let's write down the formula for lateral area of a cylinder. And that's going to be S equals 2 pi RH. So we want to write this as a function of its radius. So I can see it in the formula that we have an R, but we also have an H. So I want to replace the H with an expression that has an R in it. So let's look at what other information we know. We know that the volume of the cylinder is 400 pi. So let's write this down. Volume of a cylinder formula is volume equals pi R squared H. So what I want to do is, I know the volume is 400 pi, and I want to replace H over here with an expression that has R in it. So that means that I want to solve this equation for H. Okay, so to solve this for H then, I'm going to divide by pi R squared. Okay, and so the pi's are going to cancel out, and so I'm going to get that the height equals 400 divided by the radius squared. Okay, so if H equals this, then I'm going to take this and I'm going to replace H in this surface area formula with that expression. So that gives me, I've got 2 pi R, and then instead of H, I'm going to put 400 over R squared. Okay, and then you could leave it like that, but I'm going to simplify it down to a nicer equation. And so when I simplify that, I'm going to get 800 pi. And remember that this R is on top, so it'll cancel out with one of the R's over here, and I'm going to get 800 pi over R. So if I know the radius of the cylinder, then I could just plug it into this formula and find its lateral surface area. All right, so that's kind of what we've been doing. Now let's take it a step further. Let's look at a different type of function application with these cylinders. So example 2 says an empty cylindrical swimming pool has a height of 5 feet and a diameter of 18 feet. Water is flowing into the pool at a constant rate. After 60 minutes, the height of the water in the swimming pool is 2 feet. So it says sketch a picture of the problem situation. So let's just sketch a picture of this swimming pool. I have a swimming pool in my backyard, kind of like this. And we know that the radius has a height of 5. And we know the diameter is 18, so therefore we know the radius is 9. Sorry, my pen's a little bit off here. All right, so, and water's flowing into this at a constant rate. We just don't know at what rate right now, okay? But we do know after 60 minutes the height in the pool is 2 feet. So B says, what is the volume of the water in the pool after 60 minutes? So if we want to find the volume, this is a cylinder, so volume is pi R squared H, area of the base times the height, or pi R squared H, and we know that the radius is 9. And after 60 minutes, what's the height of the water in the swimming pool? It is 2 feet. So I'm going to plug in 2. And so then my volume, I just worked that out, and my volume is going to be 81 times 2, which is 162 pi feet cubed. Now we're going to leave this exact because it does not say it around. Okay? Now, what is the rate at which water is flowing into the pool? Well, if the volume of the water is 162 pi after 60 minutes, Then the rate is, we want to know how much it is per minute. So what's the volume at 1 minute? So, because it's flowing in at a constant rate, so the rate's going to be the same. So if you work that out, you're just going to take 162 pi and divide it by 60, and that rate works out to about 2.7 pi feet cubed per minute. So the water's flowing into the pool at a rate of about 2.7 pi cubic feet per minute. Now, D says express the volume of the water in the pool as a function of its height. So as a function of the height. So the volume of the pool is pi r squared h is our formula, but we want it to be a function of the height. So we want the formula to have only h's in it. So we want to replace this r with an expression that has h in it. So in this case though, for a cylinder, as the water's going into the pool and it's filling up, does the radius change at all? No, the swimming pool always has a radius of 9. It's not going to change. So I can go ahead and replace the r with 9, and that's going to always stay the same. So the volume as a function of its height is going to be 81 pi times the height. So whatever the height is, I can plug it into this formula and figure out what the volume of the water is. Okay, so then it says, what is the volume of the water if the height is 4 feet? So I'm going to use my formula as a function of the height. Means it depends on what the height is. So if the height is 4, that means I'm going to plug in 4 into my formula for h. So 81 times 4 would be 324 pi cubic feet. Okay, so for cylinders, the radius is not going to change, and so you can just look at different ways of writing the formulas and based on the height or the radius. All right, and that's all for cylinders. Next lesson will be over cones.